Welcome to Business Math. Today happens to be February 14th. So happy Valentine's Day. Or I heard also, if you want to be politically correct, happy Single Awareness Day. So I just found that out this morning. Well, I always like to occasionally, at least, go over some real math problems out there in the real world. So I don't want to take too much time because we got to get back to statistics, but it's related to what we've been studying. So here's the problem. All right, let's go straight to the computer, and let's open up a browser, and let's go to Chevrolet.com, and we're going to do a little car analysis using some of the skills that we have been learning in class, okay? So, here's the question. The Chevrolet has come out with a, let me zoom out a little bit so I can see what I'm doing here. Chevrolet has come out with a diesel Chevy Cruze, and if you'll notice, it's 46 highway miles per gallon. Okay, 46 highway miles per gallon. Then they also have the Chevy Cruze Eco that gets 42 miles per gallon. So the question, if we go through the UDI process, understand the problem, devise a plan, implement the plan, and then evaluate the solution of the plan. To understand the problem is the question: is it worth it to buy the Chevy Cruze diesel versus the Chevy Cruze Eco, which gets 42 miles per gallon? So you have the gas version of the Chevy Cruze gets 42 miles per gallon, and then the diesel gets 46 miles per gallon. Now, in a real-life problem like this, what are some of the things that we should ask ourselves? Let's go to Courtney in Woodward. Because the question is it worth it to buy the diesel? So what are some of the other questions to help us answer that? Courtney and Woodward. Is it worth it? Well, if you were going to decide, let's make this real, Courtney. If you're going to decide, hey, should you buy the gas or you should buy the diesel? What's something you would consider? They're both nice cars. It's the Chevy Cruze gas version, the Chevy Cruze diesel. What's something you would consider? This is a real life problem. How would you decide? In other words, how would you decide which one to buy? Courtney, go ahead.
Which spends less money for gas?
I'm sorry, go ahead a little louder.
Which one spends less money for gas?
So you'd buy the diesel, okay? Because it got 46 miles per gallon, okay? 2 points for your good participation. Okay, what's something you would consider? Let's go to Ponca City. Wyatt, go for it.
What the average price per gallon is?
Whoa, Wyatt, you are awesome. Yes, we do have to know the price of gasoline versus the price of diesel. Right now, on my way across town, I don't know what it is where you are, but one of the gas stations that I pass was selling gas at $3.19.9 a gallon, and the other one was selling gas at $3.63.9, or diesel at $3.63.9 a gallon. So Wyatt, that is awesome. Now we have some more information. See, we're in the process of devising a plan. So Wyatt moved into to devise a plan. It sure would be nice to know what the price per gallon of the fuel is that we're using. All right, now Robert, let's see, continue. What do we do next?
I don't know. I just got here.
All right, let's go to Shay.
What was the question?
All right, let's go to Jonte.
Which car is cheap?
Yeah, which car to buy? That's the one that we're asking. Should we buy the gas Chevy Cruze, or should we buy the diesel Chevy Cruze?
I'm saying which one? I'm saying the one which is cheaper. Far as
there you go. So we need more information. So Jonte says, let's take a look at the price of the two vehicles. That's very important. Good answer, Jonte. Because are they the same price? Does one cost more than the other? Well, let's see. It says, let's go right up into here. Let's click on the Chevy Cruze and see what it tells us on the various Chevy Cruze vehicles. Okay. Oh, it says here that the Chevy Cruze starts at $17,500. I don't know if you can read that.
It's not. Our computer's not on in an hour.
Oh, so you need to get somebody. Do you have you don't have a facilitator, huh?
Not
No.
today.
You might want to go get somebody. The Chevy Cruze, the diesel version, we're going to have to compare the price to the gas version. Okay? So we're going to click on Build and Price here. So we're going to build and price our 2014 Cruze. Now, it depends on if you get, I don't want to spend too terribly much time on this, but the diesel, it might take your screen a while to catch up. But the diesel cost, this is down here, there's the diesel cost, it's about $26,000, and the gas, the cheapest gas one is like $18,000. So Jonte, good answer. The diesel costs $8,000 more than the gas version. All right. So that's something very, very important to realize that hey, they don't even cost the same.
Right.
Well, I'm sorry. Go ahead.
We said you needed a truck instead of the car.
Yeah, get the truck, right? But we're trying to go apples to apples here to see if that extra 46 miles per gallon versus 42 miles per gallon is actually worth it. Well, let's pretend, I don't want to take too much more time on this, but let's pretend that the two vehicles cost identical. They cost the same. But Jonte, I love your observation. You do have to know how much, and usually diesel almost always costs more than gas engine. Now one of you might know why. Does anybody know why a diesel costs more than a gas engine? Anybody know why? Anybody know how a diesel engine works versus a gas engine? Nobody knows, huh? Well, you're all gonna learn something. You learn something today. The gas engine actually has a spark plug. So when it compresses the fuel, the spark plug ignites the gas, and boom, that propels the engine. The diesel engine, on the other hand, it compresses the fuel so hard that it literally creates an explosion. Boom! So the engine, for a diesel engine, it has to be way, way stronger in construction. It has to be heavier metal, more solid, bigger, thicker, and so consequently the diesel engines are more expensive. That's at least I'm not a professional mechanic. I just look like one, right, John Day? But anyway, yeah, I just look like a professional mechanic. I've got a busted knuckle up here. But anyway, so let's pretend right now, these are called your assumptions when you solve a problem. When you solve a real-life problem, a lot of times what you do is you put in a list of assumptions to make the problem easier. Remember, if you go back to your list of problem-solving techniques, one of them was make the problem simpler. So when we make a problem simpler, a lot of times we'll put in assumptions that aren't even true, but they will make the problem simpler. So John Tay's absolutely right. You want to know, hey, do these vehicles cost the same? All right? And the answer is no. The diesel costs $8,000 more than the gas. So right there, you probably say, wow, $8,000, that's going to buy a lot of gas. That's going to buy a lot of gas. Then in real life, you're going to have to look at other things because people that live way up north, they hate diesels. Anybody know why people way up north hate diesels?
Because they hate plugging them in.
I'm sorry, because what?
Yeah, we just.
Because they hate plugging them in.
Oh, they hate plugging them in because a diesel, you see a diesel fuel, unless you put an additive in it, a diesel fuel in cold weather will actually gel. Some of you didn't know that. Gasoline will not. So you have to plug in your diesel engine or add fuel additive or something because otherwise you're going to have deep problems in the cold. Well, anyway. Any more comments on that? We'll move on.
Really?
Yeah, in fact, way up north, all the cars pretty much have a cord coming out the front end. It's called the head bolt heater. Anyway, well, I want to talk a little bit about ratios. Then we have to talk about standard deviation today. All right, so if we're talking about ratios here, now we'll see how good your estimation skills are. Percentage, what percent more is the diesel fuel mileage than the gas engine fuel mileage? In other words, 46 is what percent more than 42? Can you answer that question? How do we answer that question? 46 is what percent more than 42? I'm going to write that down. 46 is what percent more than 42? I want to know that. All right, how do you do that, Shay? I think this comes from last chapter. 42 or 46. Go ahead.
The difference divided by 42?
Good. Get the difference. So you have to take the difference between these two, which is 4. Okay, so the difference between those is 4. And then we're saying more than 42. So there's our basis. 42 is the basis because that's what we're comparing it to. 46 is what percent more than 42. When you see more than 42, that means 42 is the basis. Right after the more than, because we're comparing to 42. So we go 4 over 42. Now, if you take your handy-dandy calculator, now most of you, I hope you can give me a rough approximation with that without using your calculator. Can you give me a rough approximation of that, Robert?
About 9%, 12 or 9.
That's a good guess. Now take your handy-dandy calculator and see if you're right. Let's see. Get your calculator out. See if it were 4 out of 40, it would be 10%, wouldn't it?
Yes.
So if it were 4 out of 40, it'd be 10%. So 9% is a really good guess. 10% would be an estimate. And the reason it's so important to estimate your answers is because that way if you come up with some totally unrealistic answer on your calculator, you'll catch it. So it's a good idea to estimate first. And get it exactly on the calculator. We got 0.095 and a bunch. In other words, so 10% was a good guess, 9% was a good guess. So the answer is 9%. Now you're getting 9% better gas mileage, 9% better gas mileage, or better fuel mileage on the diesel. 9% better. Now let's see how much more your fuel costs you. So the question now is, we want to erase these two things here, and we want to say $3, let's round it to $3.64, that'll be close enough. $3.64, that's the price of diesel per gallon, is what percent more than $3.20? So, same type of thing. Okay, tell me which one's the basis, the $3.64 or the $3.20? Why?
The 320.
Excellent. 320 is the basis. So now, instead of taking 4 divided by 42, we take the difference between these two. Let's see, I think I used to be good at math. Is that about 44 cents? Is that 44 cents, Courtney?
Yes.
All right. So we'll take the we will take the 0.44 over the base is 320. Now, right off the top of your head, I'm hoping that you realize that that's bigger than 10%. Because if the numerator was 32 cents, then it would be 10%. The numerator is 44 cents. So if you take 0.44 divided by 320. All right, did anybody do that? Anybody get that? What is it?
13.75%.
And that was Wyatt, correct?
Yep.
Wyatt, you get the extra credit on a Friday for being the first one to answer. All right. 13.75% is the correct answer. So, right here, you get 9% better gas mileage, or fuel mileage, 9% better fuel mileage, and you're going to pay 13.75% more for your fuel. Even if we rounded these, I think it was 9.5%. So even if we rounded them, it would come up to 10%. You get 10% better gas mileage, but it costs you 14% more for your fuel. So now back to Courtney. So what do you think, Courtney? Is that a good deal?
No.
No, it's not. And that's even if they cost the same. Now, for those of you that are truck aficionados, there are other factors. See, when you do real world, there's other factors to consider, because if you are it's my daughter-in-law's father is a professional truck driver, 18-wheeler, okay?
Yeah, Peterbilt.
He drives professionally. He's driven over 1 million miles in his life, okay? The diesel engine will last way longer than a gas engine. So there are other questions to ask. But just from an operating standpoint, I wanted you to do that. Well, I'm not going to take the time. But you could do the same type of mathematical analysis with whether you should buy an electric car or not. Now, when you consider that, be sure you do apples to apples, all right? Apples to apples. When I say that expression, apples to apples, what am I talking about, Jonte?
Apples.
Yeah, apples to apples. When I say, hey, comparing apples to apples, what's that mean when I say I want to, when you consider buying an electric car, make sure you're comparing apples to apples. What's that expression mean?
It means you got this apple tree that looks so good, then you got the other apple tree on the other side that looks just delectable. But if you look at the apple, maybe this apple tree on this side to the left got worms in it. While
I love your explanation. I love it. That's awesome. Now, what it usually means to most people is you want to make sure that you're comparing like a Chevy Spark electric car to a Chevy Spark gas car. See, it's not fair to compare like a Mercedes-Benz to a Chevy Spark. That's not fair. It's not fair to compare that brand new Cadillac electric car. It's a hybrid, actually. Brand new electric car for $75,000, and compare that to a Toyota Corolla. It's not fair. So apples to apples just simply means we want to compare a Chevy Spark gas to a Chevy Spark electric, just like we did on this Chevy Cruze gas to the Chevy Cruze diesel, okay? So that's what usually people mean by apples to apples. So I'm not going to go through the explanation, but here's something, a little extra credit assignment. You can post it at the discussion board. Here we are, way in the upper left-hand corner, that's a Chevy Spark. There it is, little tiny car. Manufacturer's suggested retail price is $12,000, right? Cute little car. Now, you can also buy this in the electric version. So $12,000 for the gas version. For the electric version, even after your $7,500 credit, it's going to cost you $19,000. Same car, one's electric, one's gas. So $19,000 for the electric, $12,000 for the gas. So $7,000 more for the electric. Now, when you work this extra credit problem, you can make some assumptions. I'll let you, even if they're false, as long as you state them up front to make the problem easier. So if one assumption you want to make is electricity is free. You know it's not, right? But you can assume electricity is free. You can also assume that the maintenance costs for a gas and for an electric are exactly the same. That's a difficult one to measure because when you have to, you don't have a whole lot of maintenance on an electric vehicle, no oil to change, but those batteries are really expensive when you have to swap out your batteries, when you need new batteries. So there's a little extra credit problem for you. Is it worth the $7,000 extra for the electric vehicle? And you can assume free electricity. Assume that, okay? It's a fun little problem. Now, to answer that question, you've got to show the math. You can't just say, oh, Dr. G, I just did the extra credit problem. The electric one is not worth it. No, you got to tell me, show me the figures. You got to show me, okay, what are you assuming your cost for your gasoline? Is it $3.20 a gallon? You got to assume, okay, what kind of gas mileage? You probably can average 35 miles per gallon with this little car here. So you're going to have to do that. You're going to have to figure out how many miles and where's your break-even point. How many miles do you have to drive before you break even on, in other words, before you make that $7,000 back, right? This is real practical stuff. Well, we got to move on. Are huge concepts about statistics. One of them that we've already talked about, well, let's see, go to your notes. What a concept, right? Nobody ever told you to take notes, right? What a concept. I went over 5 huge concepts. Last time I went over 3 of them. Name me a huge concept when it comes to statistics. Let's go to John Day.
Standard deviation.
Standard deviation is a huge concept, and we will do that today. We're going to talk about that. But that's actually a measure, that's actually a statistic, all right? And we will get there, so you get your 2 points for that. I'm talking about these gigantic concepts of statistics. Courtney, name me a gigantic concept. Averages, yes. Which average are you using? Is it the mean? Is it the median? Or is it the mode? And in fact, I think I even put these right here. So, these are the 3 that I talked about last time. I talked about average. Is it the mean, the median, or the mode? That was a big one. That was this one right here. All right? And if we want to talk about average salary in the city of Enid, Oklahoma, average salary in the city of Enid, Oklahoma, which one would be the most fair average to report? The mean, the median, or the mode? Wyatt?
Median.
The median, exactly. Because the median is not affected by extreme scores. Remember my example I gave you? I gave you a company that has 10 employees. 9 out of the 10 employees don't make jack squat, but the president of the company made like $620,000 a year. Well, if the president wants to report statistics and make his company look like he's really a high-paying company, he would use the mean, because when you add up all 10 scores, or all 10 salaries including his, divide by 10, it came up to something ridiculous like $87,000. And out of the 9 employees, other than him, there wasn't even one of the employees that made $87,000. So mean can be affected by extreme values. All right. Another one, huge concept. Besides averages, what's another huge concept, Robert?
Bell curve.
Yep, the bell-shaped curve. In other words, is the data going to be a nice bell-shaped curve? And here's how you tell. Here's a real easy way to tell whether is just to ask this question. It's kind of just it's a mind puzzle. That's what it is. It's just a thought puzzle. Imagine taking 1,000 people from Enid and putting them right outside here in this empty lot. And these are random sample, by the way, which is that's another big concept, isn't it? Random sample, because is your sample really random? You see, if I went and got my sample down at Jack's where they sell all the lottery tickets, and I do my random sample from people standing in line getting their lottery ticket, do you think that's a random sample, Shay?
No.
No, not even close. The people that are standing in line over here at Jack's gas station getting lottery tickets, most of them don't even have any teeth. And the ones that do have a few teeth, they don't even brush their teeth, okay? Now my point is that it's not a random sample. It's amazing that it's mainly poor people buying lottery tickets, okay? You know, and it's understandable because, hey, you're just hoping for, you're buying hope. That's what you're doing, hey. But that's not a random sample. So pretend that we've done a really good job of getting a random sample of 1,000 people out here, and I put them right out here. We just did an excellent job. We were very careful to make sure we got a random sample of 1,000 people. All right. Now we measure things, and these are only adults, 18 and over. I'm going to even make that simple, okay? These are 18 and over. So we measure the average height of these 1,000 people. There's men and women here. So what do you think the average height would be, Jonte?
Average height for men and women?
Men and women, yeah. Average height, you got men and women. So you got 500 men in there, 500 women. Let's say that's random. And so you got
5'2", 5'5".
Yeah, something in there. You know, in fact, I think we looked this up before on the internet. And if we just said average height of an American, this is what's so cool about the internet here. We can go right up into here, type Google, and we can say average height of an American. Average height, not of an American man, of an American. Period. Not man, not woman. Okay. Now, the average height for an adult female is 64 inches. Okay, that was right here. 64 inches. So that's what? That's 5'4". And then I think we did the average height of a man was it 5'10". So let's just say let's see, halfway between 5'4" and 5'10" is how much? What? What's halfway between 5'4" and 5'10"?
6 inches?
Well, you got 6 inches between 5'4" and 5'10". Now what halfway between 5'4" and 5'10"? It's 5'4" is the female. 5'4" is the female. 5'10" is the average height of the male. We want to go right halfway in between 5'4" and 5'10".
5'7"?
5'7" is correct. So, and there's a couple of different ways you can do that. One of them is just there's 6 inches there, cut the 6 inches in half, you get 3 inches. Either subtract 3 inches from here, add 3 inches there. 5'7". So, 67 inches is the average. 67 inches is the average. Gotta watch that clock carefully. Okay, 67 inches. In fact, height is going to give you a nice bell-shaped curve, and right here is 67 inches. 67 inches. That's the average height of a person in America, and we'll assume Enid is pretty much average, okay? So, without shoes, I'm actually below average in height, which is not a surprise, all right? So that's 67 inches. Now I got 1,000 people. We'll see how good your this is not mathematical calculation. This is just how good your mathematical estimation or common sense is. So, let's say the tallest human alive visits Enid, Oklahoma. So we go back over here to Google, and we say, tallest human. Tallest human. All right. Tallest human. Oh, it looks like about 8 feet. Okay? That looks like about the tallest human ever was about 8 feet tall. Okay? Sometimes it's hard to verify some of this stuff, but we'll say 8 feet tall. So, we take out the shortest person out of this 1,000 people and replace that with the tallest person. Okay? Now, do you think that 67 inches average would budge very much? Do you think that 67 inches average would budge very much? What do you think, Courtney? No, it wouldn't. You're absolutely right. Because, see, we're dividing by 1,000. And in fact, let's say the shortest person was 4 feet tall, and the tallest person was 8 feet tall. We're only adding 4 feet, which is 48 inches, to the total. When you add up the heights of all 1,000 people, you're only adding 48 inches on the total. 48 divided by 1,000 is not even a half an inch, is it? See, 48 divided by 1,000 is, wow, that's small. 48 divided by 1,000, see, the reason I got 48 is I figured, let's replace a 4-foot person with an 8-foot person. So I got 48 inches more on my total. When we divide that by 1,000, we move the decimal point 3 places. The average is only going to be, it's not even going to be 1/10 of an inch. It's not even going to budge this average 1/10 of an inch. So this is the way that you can tell whether a set of data has a nice normal distribution to it with no tremendous outliers. This data is actually called Gaussian. It's not a really big deal. But now let's take an example of the 1,000 people out here, random sample, and their average net worth. I think I already hinted towards this before. The average net worth, let's pretend, make the numbers real simple because I'm running out of time. The average net worth is probably, let's say, about $100,000, okay, of these 1,000 people. Now I replace the poorest person out there, and Harold Hamm happens to be visiting in town, and he's worth $10 billion. $10 billion. All right? So now we replace somebody. Let's take the poorest person there that actually has 0 net worth and replace them with Harold Hamm. $10 billion. So when we add up and divide by 1,000, watch what's going to happen to the average. Watch what's going to happen. You're increasing the total by $10 billion. Take $10 billion and divide it by 1,000. All right, let's write out what 10 billion is. Let's see, there's 10,000, 10 million, 10 billion. What's the shortcut way for dividing by 1,000? What's the shortcut way for dividing by 1,000, Shay? Take off 3 zeros, okay? You get 2 points for your good participation. When you divide by 1,000, you take off 3 zeros. You take off 3 zeros. In other words, look what happened to the average net worth. The average net worth jumped from 100,000 to $10 billion. Now you know net worth is not a nice, normal distribution because you take one outlier, like Harold Hamm, and he just blows this 100,000 average right out of the water, and now the average is $10 million. So that's another reason why when we have outliers, it's very important that we use median. Now we have about 5 minutes to talk about standard deviation. standard deviation is simply, it's very important that you understand what the concept is. The concept is how spread out are the scores? How spread out are the scores? Now, you can do this. You can collect data on just about anything. And let's say we've collected data on running backs in football. Let's say we've collected data on running backs in football. And so we have two running backs. We have a running back that's a fullback, and he's really good at making short yards. He's a fullback. His average, and by the way, we're saying mean, his average per carry is only 4 yards per carry. That's all he averages. 4 yards per carry. Then you got this real fast halfback. And his average yards per carry is 10 yards per carry. Okay? His average is 10 yards per carry. Now, a couple things. Now here's the scenario. We are on the goal line on the 2-yard line. We're on the we're on the 2-yard line. Okay? We're currently on the 2-yard line. Couple more pieces of information. The standard deviation for the fullback, he is really consistent, meaning 0.5 yards. In other words, on a bell-shaped curve, 68% of the time, he will actually run between 3.5 yards and 4.5 yards. 68% of the time, he'll be between those two. Now, the halfback, on the other hand, probably has some really big outliers that really changes 10 yards per carry. And in fact, if we include all those outliers, he might even have 20 yards per carry. All right? But here's the kicker. His standard deviation is just huge. His standard deviation is like 19. That's a standard deviation. In other words, he's kind of erratic. Sometimes this halfback actually gets thrown for a loss. Sometimes the halfback runs it, for 80 yards. So you're on the 2-yard line, and with this data right in here, who are you going to give it to, the fullback or the halfback? Dante.
I'm going to tell you like this. I'm going to give it to that fullback.
You better believe it. You're going to give it to the fullback because the fullback is consistent. See, the fullback, he's not the fastest guy in the world. He only averages 4 yards per carry, but boy, he's consistent. Oh, now some of you might say, yeah, let the fullback block for the halfback, right? Send the fullback to the hole first. But just based on this data right in here, I would give it to the fullback. And here's the reason why. If you take and you look at the bell-shaped curve of both of these running backs. So if we take a look at the bell-shaped curve of the fullback. The fullback, boy, he has a really tight bell-shaped curve. Right in here, his average was 4, and 68% of the time, he scores between 3.5 yards and 4.5 yards. That's 68% of the time. This is in your book. You can look at it. In fact, it is on page 145. 68% of the time, he scores between 3.5 yards and 4.5 yards. In fact, 95% of the time, he scores between 3 yards and 5 yards. That's going out one more standard deviation. So 68% of the time, he's going to score between 3.5 yards and 4.5 yards. between these two. But between these two, 3.5 and 5.0, 95% of the time. So I would give it to the fullback. All right? Now, the halfback, what does his bell-shaped curve look like? The halfback's bell-shaped curve looks like this. The halfback's bell-shaped curve looks like this. It's real wide, meaning sometimes he has runs, I said it was 20, the standard deviation was 19. Let's make it real easy. Well, I'll stick with 19. 19 is the standard deviation, so if we go up to 39, subtract 19, we're down to 1. So 68% of the time, he's between these two categories here. But we can't really count on him in the short yard situation. Because even this, he's had some outliers out here. He's had some 99-yard run backs that you get the point. Standard deviation is how much the scores are spread out. Now, your author goes through the calculation very carefully. So the first step that we're going to do is we have to take every score, and we have to, first of all, we got to figure out the mean. Then we have to figure out how much does every score vary from the mean. And then what we will do is, the actual mathematics of it is, we will actually square those scores to get rid of the negative signs. We will add those up and average those by the number of scores. Now, I don't have time to go over that today. This assignment won't be due until Monday night, so I will have time to walk through on Monday an actual calculation of a standard deviation. So you do the best you can. The assignment's not due until Monday night, so I will on Monday go over an exact calculation of the standard deviation. You guys did great today. Have a wonderful Valentine's Day. I'll see